let's discuss sigma notations 3.6. This is the sigma symbol. It's a Greek letter. We are going to use this symbol uh, to show the summation. Let me start with the example. 1, 3, 5, 7, 9. And you can see this is a sequence. This is arithmetic sequence. I'll make it into a series now. And this is the first term. I will write this term as first term, and the second term, and third term, and fourth, and fifth. And I have to add this first term, second term, third, fourth, fifth terms. We have to add. So this idea I can write simply rather than writing 5 terms like this. I will define a common one, FR. Then FR, then summation R equal 1 to, because 5 terms, 1 to 5. The idea is R has values 1, 2, 3, 4, 5. So R goes 1 to 5. When R equal 1, write F1. When R equal 2, write F2. When R equal 3, F3. And R equal 4, F4. And R equal 5, F5. And then add. So this is the idea behind this. Let's discuss another one. Summation R equal 3 to 5 FR. Then when R equal 3, so this is going to be F3. So this is R equal 4. So R value 3, 4, 5. Then F4 and F5. Oh, let's discuss another one. So then in here, we don't discuss F1 and F2, F3 is F5. R value is 2 to 4. It means F1 missing, F2, R values 2, 3, 4, F3 and F4. So we have to add these three. So the first one missing, last one missing. Basically, the idea behind it, we have to follow this R value from where to where. So here we have to add first term to fifth term. Here we have to add 3 term to fifth term. So here we have to add 2 terms to fourth term. Now, assume we want to find this one, R equal 3 to 5. We want to add F3 plus F4 plus F5. So we can find this one. Well, how do you write F1 plus F2? Summation R equal 1 to 2 FR plus. Now I'll bring this one to left side. Or let me do differently. Assume we need to find r equal 3 to 5. So I can find r equal 3 to 5. That is summation r equal 3 to 5 if this bit. This one summation r equal 1 to 2 if this 2 I write r equal 1 to 2. Now we know this is r equal 1 to 5 if then I'll bring this one to left. Summation r equal 1 to 5 if minus summation r equal 1 to 2 if equal summation r equal 3 to 5 if so we need to find if 5 plus 7 plus 9. So what we did was r equal 1 to 5 if we found whole total up to here, that is this idea. Then we are minusing those two, 1 to 2. Then we can get this bit. So you may need this idea to work out the sums. Now we'll go back to the initial level. So this is 1 and this is those are the terms. And now we know that we can write simply this one using sigma notation, r equal 1 to 5 if now let's see a short way of writing this. Now we know that this is an arithmetic series. How do you write the nth term of arithmetic series? That is Tn equal a plus n minus 1 d. So how do you what is the a? A equal 1 and n minus 1 times d equal 2. So that is Tn. So Tn equal, if I simplify, 1 plus 2n minus 2, 2n minus 2, that is 2n minus 1. 2n, this is minus 2 plus 1 minus 1. So Tn. So how do we write the r term? Tr is 2r minus 1. So now we can write the r term. Tro, we can write fr as well. So r equal 1 to 5 2r minus 1 equal, how do you write f1 now? F1 mean when r value equal 1, 2 times r equal 1 minus 1, because r go 1 to 5, 1, 2, 3, 4, 5. Then what is f2? That is 2 times r mean 2 now minus 1. Now f3, 2 times, now we have to put instead of r 3, 2 times 3 minus 1. and 4. 2 times r equal now 4. 4 minus 1. And then last one, 2 times 5 minus 1. We know that 2 times 1 minus 1 is 1. 2 times 2, 4 minus 1 is 3. 2 times 3 minus 1 is 5. And this is 7 and this is 9. Now let's generalize this idea. Before that, let me answer this question. I need to find r equal 2 to 4 on this. So how do you find? That is 2r minus 1. So this is the series 2r minus 1. So you can do that. So 2 to 4. So this is the 2, 3, 4. 2, 3, 4. So you can find r equal 1 to 4. So up to here, 2r minus 1 minus r equal 1 to, actually it is not that good, not r equal 1 to 1. So let me write like that, because only one term you can write instead of this one a, the first term, but I will write like that. So we want to find 3 plus 5 plus 7 addition. So basically 7 plus 5, 12, plus 3, 15. So instead of we are finding this one, uh, this is 1 to 4. The whole is 1 plus 4, so that is 16. And then minus the r equal 1 to 1 means the first one, first term. First term is 1. So 16 minus 1 is 15. So this is the idea behind it. You may need to use this one. Now let's generalize this idea. Assume now I want to find this series up to nth term. So this is first, second, third, fourth, fifth, F2, F3, up to nth term. Basically we need to find summation r equal 1 to n, 2r minus 1. So this is the 2r minus 1 series. Now, okay, let's forget about this one. How do you find 1, 3 plus 5, 7, 9 up to n? Nth term here. So we can find, we have a formula, Sn equal n divided by 2, 2a plus n minus 1 d. So n divided by 2, that is, yeah, as it is, we need up to nth. 2 times a is 1 and n minus 1 times d, that is 2. So n minus 2, that is going to be 2n minus 1. 2 times n, 2n minus 2. Sorry, we had to work out. So this is 2 times 1, 2. 2n minus 2. 2 to 2 cancel out, and then n divided by 2 times 2n, 2 to 2, that is going to be n square. So we know that r equal 1 to n. So up to n term addition is what? N square. So I match with this one. Up to n terms, this is n square. Let's see whether this is true or not. Let's take n equal 3. R equal 1 to 3. 2r minus 1 mean we can simplify 3 square, n equal 3. So that is 9. So, so we have to add 3 terms. Let's see whether that is right. 1 plus 3 plus 5, 8 and 9. That's what. Yeah, 5 plus 3, 8 plus 1, 9. So let's see n equal 4. R equal 1 to 4. 2r minus 1. That is, now n value is 4. 4 square 16. So 3 plus, so up to here 9. 9 plus 7, 16. Yeah, it is working. So it is easy now. We can calculate. I want to calculate. Okay, up to 16 terms. Okay, so I'll write few other terms. 9, 11, 13, 15. So F6, F7, F8. Now I want to find the addition R equal 1 to, sorry, R equal 5 to 8 to R minus 1. So basically 5 to 8. I want to add 9 plus 11 plus 13 plus 15. So instead of that I can do R equal 1 to 8 to R minus 1 up to here, and then minus R equal 1 to 4 to R minus 1. Because we have a simple rule, we can have a formula. I can find easily addition from 1, not any other number from 1. That's why I wrote this 5 to 8 in terms of starting with 1. So now I know that 1 to 8 I can simply write 8 square. 1 to 8 I can write 8 square, and then I can simply write 1 to 4, 1 to 4, 4 square, right? So 8 minus 4, difference of 2 is square, 8 plus 4. 4 times 12, that is 48. So is that right now? Let's see. 15 plus 13, 28, 38, 39, 48. Yeah. The addition of these is 48. Let's consider the natural numbers. 1 plus 2 plus 3 plus 4 plus up to nth term. So this is n term is, okay, this one. So what is this series? It's arithmetic series. Just we'll write in terms of r. So what is the nth term? So Tn equal a plus n minus 1d. A is 1 plus n minus 1 times d is 1 again. So 1 plus n minus 1. So that is n. Tn is n. It means nth term is n. Fourth term is 4. Fifth term is 5th is by. So r terms is r. So we can simply write this is summation I equal assume up to nth term. So nth term we can write r simply. And what is the addition up to nth term? So n equal n divided by 2, 2a plus n minus 1 times d. So n divided by 2, 2 times 1 plus n minus 1 times 1, d is 1. So this is n divided by 2, 2 plus n minus 1, that is n divided by 2 plus n plus 1. So then you can write summation I equal 1 to n, this R series up to addition up to n is simply n divided by 2 n plus 1. Now how do you find a series R equal 1 to, let's say, 3 2R plus 1. I'm going to change to minus 1 now because we did already this one. R equal 1, then 2 times 1 minus 1, R equal 2, R value goes 1, 2, 3. 2 times 2 minus 1 and 2 times 3 minus 1. So this is 1 and this is 4 minus 1, 3, and this is 2 times 6 minus 1, 5. And in this term we discuss R equal 1 to 3, 1 to n up to n term. 2R minus 1 is n square. Now what will happen? R equal 1 to n, if you see, okay, 1 to 3, if you see 1, what is the idea behind it? This idea behind it, there is no R, then we have to put a R. So R equal 1 to 3, 1 to R to the power 0. Now R is there, R to the power 0 is 1. I didn't do any changes because 1 times 1 is 1. So this 1 I turn into R to the power 3. Now you can see that R equal 1, 1 times 1 to the power 1, this is R equal 1, 0, plus 1 times R equal, R value 1, 2, 3, 2 to the power 0, then 1 times 3 to the power 0. So this is going to be 1 time 1, 1 time 2 to the power 0 is 1, and 1 time 1. So that is 1 plus 1 plus 1, that is 3. My next question is R equal 1 to 1 times 7, 1. What is the answer? It means 1 plus 1 plus how many times? 7, 1, 2, 3, 4, 5, 6, and 7. Yeah, so addition is 7. How about R equal 1 to n? Then 1 plus 1 plus, sorry, 1 plus 1 plus dot dot plus 1. How many terms? N terms. Now this is how many terms? 7 terms 1. This is 3 terms 1 equal 3. 7 times. So likewise this is n terms times 1 equal n. Uh, how about this one? R equal 1 to 3, 2. So this is, if we want, you can write R equal 1 to 3, 2 to R 0, and you can work out like that. So basically it is simply the idea behind it. You are adding 3 terms, 2 plus 2 plus 2, that is 6. So how do you find R equal 1 to n? This one, it means 2 plus 2 plus dot dot 2, how many terms? N terms. So n terms times 2, that is 2n. Now, what is this series? 2 plus 2 plus 2 plus 2. This series is a geometric series. What is R? R equal 1. So we have two formulas for find Sn, A1 minus Rn, 1 minus R, or other one A, Rm minus 1, R minus 1. But we can only apply for this R not equal to 1. But in here you can see R equal 1. So you can manage now how to, when R equal 1, when R value is 1, you can manage how to find N. So this is basically Sn. For this series, Sn is 2n. So S5 is 2 times 5, that is 10. So S3 is 2 times n, that is 2 times 3, that is 6. And this is an extension basically. So we know that summation r equal 1 to n 2r minus 1, we work out in square, and summation r equal 1 to n, r we know that is n divided to n plus 1, and summation r equal 1 to n, just 1 we know that we found out that is n. So now I'm going to show that to forget this value using those two terms, this one and this one. So this is an extension. Summation r equal 1 to n 2r minus 1. So this sigma notation, it's like a multiplication. I will take this bracket out. So this is going to be r equal 1 to n 2r minus r equal 1 to n 1. I'm going to take this 2 out as well. It is a constant, r equal 1 to n r minus r equal 1 to n 1. So 2 times r equal 1 to n r is, that is uh, n divided by 2 n plus 1 minus, that is r equal 1 to n 1 is n. So now we'll simplify. 2 to 2 cancel out. N times n square plus n minus n times plus 1 is n minus n. So this is n square. For an example, we'll work out this one, r equal 1 to 20, 4r plus 1. So this is, I can simply write 4 times summation r equal 1 to 20 r plus r equal 1 to 21. So 4 times r equal 1 to 20. So I know 1 to n, r is n divided by 2 n plus 1. So this is going to be 20. 20 divided by 2, 20 plus 1 plus r equal 1 to 21. 120 and n, then this is 20. So then 4 times, this is 10 times 21, 20 plus 1, this is 20. So 40 times 21 plus 20. So this is going to be 210 times 4. That is 0, 4, 8 plus 20. So that is 860. In the book I can see this series. Uh, so we have to write the series, so it is so simple now. So 2 times when r equal 1 to 1 minus 3, that is 1. And the second one, um, r equal to 2 times 2 minus 3, and 2 times 3 minus 3, 2 times 4 minus 3, and the other one 2 times 3, 2 times 5 minus 3. So when you simplify this one, you will get minus 1. This is plus 1. And then this is plus 3, plus 5, and plus 7. The next one I can see in the book, r equal 1 to 7, 5 times 2 to the power now this one is 5 times 2 to the power when r equal 1 to 1, plus 5 times 2 to the power when r equal r1, 2, 3, 4, 5, 6, 7. Then this is 2 to the power 2. Then 5 times 2 to the power 3. 5 times 2 to the power this one 4. 5 times 2 to the power 5, and 5 times 2 to the power 6, and 5 times 2 to the power 7. So you will answer, when you simplify, you will see it is okay. I think in the book it is not 1 to 7, it goes to 3 to 7. Okay, that's fine. It goes, we work out 1 to 7, so this is 10, this is 20, 2 is square, and then this is 8 times 40, and then 80, 180, 160, 10, 20, 40, 80, 160, 320, and 640. In the book, it's asked 3 to 7. It means you don't need this one, this one, this one. So we cancel out. Basically, you can see in the book 80, 60, 320, 640. Example 17, the same sum, r equal 1 to 20, 4r plus 1. So we have to find up to 20 the addition. Let's do the book the way the book did. So we have to write the terms, few terms basically. When r equal 1, okay, we'll write the series r equal 1, 4, 1 plus 1, that is 1, and r equal to 4, 2 plus 1 plus 1 plus dot dot dot, r equal 20, r 20 plus 1. So this is 4 plus 1, 5, and then this is 9 plus the next one, if you do 13, and this is the 81. Now we have to work the addition after 20 terms. Now this is a which series? Arithmetic series. A is 5, D is 9 minus 5, that is 4, and we'll work up to nth term. We know as n divided by 2, 2a plus n minus 1 d, and then up to 20 terms addition is 20 over 2, 2 times A is 5 plus this is n 20 minus 1 times D is 4. So this is going to be 10. This is 10. 2 times 5 and 19 times 4. And you will get answer as 160. But you can work out like that as well. It is according to the syllabus as well as the, so for the Edexcel, for that's how the Edexcel wants. But in if you do further math, if you do the other modules, you will come across with this one. Example 18. Um, it is given part A, k equal 1 to 12. Instead of r now it is k. 5 times 3k minus 1. So basically when you look at, we have to find the addition up to 12 for this series. Right, this look like geometric series. Now what we can do, we'll write the series first, few terms. When k equal 1, 5 times 3, 1 minus 1, k equal 1. Then k equal 2, 5 times 3, 2 minus 1. Plus that is enough. Okay, one more. 5 times 3, k equal 3, that is 3 minus 1. Plus, we can write the 12th one if we want. So 5 times 3, 12 minus 1. So this is 3 to the power 0, that is 5. And this is 15. And then this is 3 square 9 times 45 plus dot dot, and so this is a equal 5. You can see this is a geometric series. R equal 15 divided by 5, 3. Now I need to find up to, so this is greater than 1, up to addition of 12. So the formula is Sn equal a Rn minus 1 over R minus 1. So n equal 20, n equal 12. So S12 is a value 5 times 320 minus 1 over 3 minus 1. 5, 320 minus 1 over 2. Not 20, sorry, it's 12. 12. So when you simplify, you may get this answer, the book answer 132 8600. Part B. So the same series, that 5 times 3k minus 1. Now we need to find not 1 to 12. We need to find 5 to 12. So 5 to 12 mean k equal 1 to 12. 5 times 3k minus 1 minus 1 to 4. So basically 1 to 12. This is 1 to 12. So we want to find 5 to 12. So 5 to 12 means 1 to 12 minus 1 to 4. So then k equal 1 to 4, 5 times 3, k minus 1. Now we know that 1 to 12, 5 times 3, 1 to 12, we found out 132 8600. Now same way you need to find 1 to 4. I can remember that is A was 5. The series was A5, R is 3. So S4 is um, A times Sn A Rn minus 1 over minus 1. S4 is 5 times R is 3 to the power 4 minus 1 over 3 minus 1. So you will get this answer as 200. So then minus 200, you will get the answer as 132 8 400. Um, Assume that only we know that instead of 5, if we know this one, um, summation 1 equal 1 to 1 to n. Okay, k equal k minus 1 if we know only this one, or we can find out as usual. Then we can work out this one, sorry, this one, k equal 1 to 12. 5 times 3k minus 1 equal 5 times summation k equal 1 to 12 3k minus 1. I took 5 out because it is a constant, and this is extension to the lesson. So 5 times this one we already found out. We can find like this, and we can sum. Same way, I can take factorize 5 here. K equal 1 to 12. 3k minus 1 minus, I take the 5 out, k equal 1 to 4, 3k minus 1. If you can't understand, just leave it this one, because this is an extension. Let's discuss in next section exercise 3F.